Alright, this is chapter 15, section 1, and we're talking about the composition of matter. The composition of matter is just basically we're going to classify and put matter into different categories. And so we're going to look at, here is a nice little chart that starts to branch matter into different regions. And so we have this broad classification of matter, where we have matter, of course, at the very top of the category. So we have matter at the top here. And so matter is, anything that has mass and takes up space. And so that's pretty much everything, right? And so chemists classify that as two things. We have pure substances, and then we have mixtures. Those are our two branches. And then so pure substances, very commonly we use substance as a very generic term. Well, substance is very specific in chemistry. We don't use substance unless it's something very, very specific. Substances can only be elements or compounds. So unless it's an element or compound, we don't use the term substance. Okay? And so then we have our terms of mixtures. Mixtures are pretty much everything else, combinations of elements and compounds put together. And then we classify those usually as heterogeneous or homogeneous, and we'll talk about what those definitions are here in a minute. Alright, so we already talked about here a little bit about pure substances, but just kind of some general definition stuff. They have fixed composition, meaning that they are in pretty much the same ratio always, and of course they can only be elements or compounds. So just talking about specifically elements, obviously we have started to study the elements. We've went through some different things with that. They build everything that we have, okay? They have the same atoms that make them up, meaning that if we talk about something like pure carbon, which is called graphite, like your pencils, they are made of 100% carbon. If we talk about the copper coating on pennies, that copper is made up of all copper atoms. Okay, there's about 90 that are found naturally on Earth, and there's about another 20 that are made in labs. And usually those lab elements are unstable and they don't last for very long. Okay, and then what we do is we take those elements and we combine them together. Usually two or more are combined together, and the key is that they are in a fixed ratio, or fixed proportion, meaning that you combine the same amount together every single time. I put an example here as table salt. Table salt is a combination of sodium and chlorine. Notice that it's one sodium and one chlorine every single time. Something that you might be used to is a formula of water. Notice that's a ratio of 2 waters to 1 oxygen every single time. Compounds always have that combination where it's always the same ratio. That's where we get into mixtures, where mixtures are a combination of 2 or more substances. And remember that we talk about substances being our elements or compounds, and that they can be separated by physical means. And we'll talk about what physical means later. That means like physical changes. So they can be separated by physical means, and we have our classification of they can be heterogeneous or homogeneous. And so these are not in the same ratio always. I like to talk about these like you could, for example, a salad would be an example of a mixture. And if you go in and take your fork and, stab a salad, you're never going to get the same ratio of stuff on your fork. There's always, sometimes you get more lettuce, sometimes you get more cheese. It just depends on, what you particularly poke at that particular time. So, if we talk about the first branch, which is the homogeneous solution, the term homo itself means same. So I like to think of this as same throughout, because these guys are blended evenly throughout. So these mixtures contain 2 or more basically substances, and they are blended evenly throughout. Things like, think of it like Kool-Aid. where if you mix the substances together, you can't pick out the Kool-Aid particles from the water particles. They're all blended evenly. Things like that. We call these solutions. Okay? So, and the particles will never settle at the bottom. That's the other thing too, is that once you mix them, they stay mixed. So those are some key components of homogeneous mixtures. Then you've got the other category. These are called heterogeneous. Heterogeneous, the term hetero itself means like different. So, if you have the term different, which I guess was right here even, they can be distinguished easily. Pick out the parts. Again, I like to use the example of a tossed salad. You can pick out the pieces of stuff that you don't like out of a salad because you can see those different pieces. Another example would be like oil and water. You know, you have oil and water in a like in a flask or a beaker or something. You can see the different layers. You can pick out the parts. Usually, even homogeneous, you can. It's more like granular. Like it's choppy. You can see the little pieces. It doesn't necessarily have to be super visual, but it's enough that you can distinguish the parts. In fact, we have a branch of the heterogeneous mixture called colloids. And this is just where the particles themselves are larger than those in our homogeneous mixtures, our solutions, but they don't settle out. Examples of this would be like your milks or your fogs. So if you can visualize those, think about like skim milk wouldn't be a good example, but think about like your heavier milks, like your vitamin D's, your 2%, your maybe even like your buttermilk, your thicker milks. Okay, or fog is a great example where you can kind of see how it's thick and you can kind of see those particles. You can test if something is a colloid by passing a light through it. If it's a solution, okay, then it can be easily seen. The light can be easily seen. It'll pass right through. If it's a colloid, it's going to scatter. So you're not going to be able to see that light. Think about headlights in a fog. Can you see headlights? No, because that colloid scatters it. Okay, so this is called the Tyndall effect. Okay, because the colloid causes the light to scatter. So that classifies the thing technically as a heterogeneous mixture that we call a colloid versus a solution. It looks like a solution. Like a lot of people be like, well, milk's a solution. It's all mixed up. But these couple of things we classify as colloids because the particles are a little bigger. Then you have these things called suspensions. These guys are heterogeneous mixtures that the visible particles actually settle out. There's not a lot of these things that I can give you examples of. And in fact, one of the few things that I can think of is like muddy pond water. So if you go and you take a cup of muddy pond water and kind of mix it up, obviously the mud's going to settle to the bottom and the water's going to go to the top. Maybe another one would be like if you take oil and water and mix it up, eventually the oil's going to settle on top and the water's going to go to the bottom. That's, some of the few things that I can think of. So there's not a lot I can give you with that. All right, that's the end.